Okay, today we're going to discuss section 112, solving one-step inequalities. Now, the great thing about inequalities is that to solve them is very similar to solving equations in most cases. So let's start with solving inequalities by adding or subtracting. And let's go through what exactly this means. First of all, solving an inequality means that you're going to find values for the variable that make the inequality true. So solving an inequality means you will find values for the variable to make the inequality true. So, for example, if I have x plus 2 is less than 5, I'm going to solve it just like I would my equation, and I would subtract 2 from either side, and I get x is less than 3. Now, it's very important that you use the symbols here because it's not like in an equation. If you don't use the symbol, we don't know what we're wanting to use for the solution. So x is less than 3 means that any number less than 3 is a solution. So 3 is not a solution because 3 is not less than 3. But anything less than 3, 2.99, 2.75, 2.6, 2, 1, 0, -1, -8, -10, any number that is less than 3 is going to be a solution to this inequality. So it's different than an equation in that it's going to actually have more than one solution. And that's the reason why we have to have the inequality symbol there to tell us what those solutions are going to be. We can't possibly write all of the solutions. It's an infinite number of solutions. And so this symbol tells us that. So we need to make sure we have that symbol there. So we've already done the example there. X plus 2 is less than 5. Subtract 2 from both sides. X is less than 3. And that's what it means then. All right, let's look at the addition and subtraction properties for solving inequalities. And basically, these are going to be very similar to your equation solving notes if you look back at those for those properties. And it just says that when you add or subtract the same number from each side of an inequality, the inequality remains true. So just like with an equation, what we do to one side of the inequality, we have to do to the other side. So you can't take something from one side and not take it from the other side. You can't add something to one side and not add it to the other side. So let's take a look at the examples down here. For number 1, we have c minus -2 is less than 3. Now we've talked about these on several occasions that when you have this minus a negative, we'll highlight that, it becomes a positive. So the inequality will be c plus 2 is less than 3. Once you get to here, it should be very easy to isolate your variable. Same thing that we were to do in equations, we do in inequalities. We isolate the variable. To isolate this variable, we have a positive 2, so we need to subtract 2 from both sides. When you subtract 2 from both sides, you get c is less than 1 as your solution. That means that any number less than 1 is a solution to the inequality. But not 1, because 1 is not less than 1. 1 is equal to 1. So number 2 says negative 13 is greater than or equal to 9 plus x. So let's highlight our variable. So that's what we want to isolate. And if we put a box then around what we have left, we have positive 9, so we know that we need to subtract 9 from both sides. Now, for some of you, I still think it's easier if you show your work in this way. If you have negative 13 minus 9 greater than or equal to 9 minus 9 plus x. Side to side is sometimes easier for you to see. So 13 minus 9 is negative 13. Remember your subtraction rule is same, opposite, opposite. Is greater than or equal to, remember that these two are going to cancel, and we're left with x, and negative 13 plus negative 9 is negative 22. So negative 22 is greater than or equal to x. Now one thing that we need to make sure of on these, especially when we start to graph the inequalities on a number line, is that our variable needs to be on the left. In order for that variable to be on the left, we have to change our symbol to the opposite symbol. So x is less than or equal to negative 22. So make yourself a note. When you change your variable to the left, you're going to flip the symbol. And it's very important that we learn to do this. So when you change your variable to the left side of the inequality, you have to flip that symbol from greater than or equal to less than or equal to. All right, let's take a look at the next page. On these, we're going to solve an inequality using addition. Now, I know some of these are difficult, and that's why I'm going through some of these with you. But let's take a look at this. We've talked about this before. When you have a plus and negative together, it becomes subtraction. So f is minus 4 is greater than or equal to 1.4. We've also talked about decimals, so we need to get better with doing decimals. So here, we want to isolate f. We want f to be by itself. That leaves us with a negative 4, so we know we're going to add 4 to both sides. And when you do this, you're going to get f is greater than or equal to 5.4 because you line up your decimal points and 4 is the same as 4.0. So this would be our solution. Now let's take a look at number 2. Number 2's got a fraction in it, which is going to cause us to have to do some work with that fraction. So let's isolate our variable. That leaves us with a negative 1, so we're going to add 1 to both sides. And now we have to, in order to add a fraction and a whole number, we have to get a common denominator. So we have negative 3/4 plus 1 over 1, because if I make 1 a fraction, it becomes 1 over 1. Now I need them both to have the same denominator, so the least common denominator is going to be 4. In order to make 1 4, I have to multiply it by 4, and so I will also multiply my numerator by 4. So that means I have negative 3/4 plus 4 over 4. When I'm adding fractions, for my answer, my denominator is going to stay the same, so we'll just leave the 4 here. And then we add negative 3 plus positive 4, and that's going to be 1. So the answer is going to be 1/4 is less than W. But now we talked about that we need to move our variable to the left side. So when we do that, we're going to flip our symbol, and it'll be W is greater than 1/4. Okay, so change variable to left. Flip symbol. Okay, now I know those were hard, and I'll try not to give you ones that are quite that difficult, although we do need to start learning to work with decimals and fractions again. So the next thing we're going to do is graph the solutions of inequalities. And what I want to do with that is to talk about, first of all, how we're going to graph them. So we want to write down our symbols. We've got greater than less than, greater than or equal to, less than or equal to. So whenever you graph an inequality with greater than, you're going to graph, with an open dot, not a closed dot, with an open dot. Less than is also going to be an open dot. Greater than or equal to is going to be a closed dot. We'll talk about why in just a minute. And less than or equal to is going to be a closed dot. Now, as long as your variable is on the left side of your inequality, these are going to be real simple to do. So let's look at a simple inequality. Let's look at x plus 5 is less than 6. Now, we know that we need to subtract 5 from both sides, and we get x is less than 1. Because we have less than, we're going to first of all go ahead and draw our number line. And our solution is x is less than 1, so we're going to put an open circle on the 1. And then if you look at your symbol, it points to the left side, but then we should also know if x is less than 1, then all the numbers that are less than 1 are going to go this direction. So we're going to draw our arrow this way. And that is how we graph the solution of the inequality x is less than 1. And we'll practice some more of those in class. Let's look at the next page. On the next page, there are some practice problems for you to do. And so I want you to take some time and go ahead and work through these problems. Make sure that you move your variable to the left if it isn't moved to the left. And then come back and I'll show you the answers and you can see what you did wrong or if you got them correct. And if you got them wrong, you'll be able to spend some time and see if you can figure out what you did wrong. Okay, hopefully you had some time to work the problems. I'm going to show you the answers. If you didn't get the correct answer, I want you to take some time and see if you can figure out what you did wrong. So number 1, p plus 7 is less than 9. The answer is going to be p is less than 2. On number 2, remember that you've got a variable on the right, so you're going to have to switch it to the left when you get finished getting your solution, not before that. And so your answer is going to be c is greater than negative 4.1. Number 3, again, you've got a variable on the right that you'll change to the left after you get your solution, and you're going to get w is less than 6. Number 4, the answer should be j is less than or equal to negative 4. Number 5, when you get your solution, it should be z is greater than or equal to negative 1.8. And number 6, and this is probably the hardest one, when you get your answer, you should get b is less than or equal to 3 1/4. If you didn't get those correct, then I want you to take some time, see if you can figure out what you did wrong, and we'll discuss those in class. We're going to end the lesson here so that we can practice adding and subtracting inequalities in class, and then we'll do the second part, multiplying or dividing, in the next lesson.